Hi guys, welcome to Calculus Crush. Today we're going to be doing an implicit differentiation problem. We've got this expression here, e to the y times cos x equals 1 plus sine xy, and we want to find dy by dx. That's the derivative of y with respect to x. Now, when I go through this, I am just going to be calling this y prime. I'm not going to be writing d by dx all over the place just because it takes a lot more effort to write. So I'm just going to be using y prime in place of it. Now this is implicit differentiation because we cannot solve for y before we get started. Y is always going to be mixed up on both sides. There's no way to get it all on one side, just have y equals a bunch of x's. We can't do that. So we just need to hit it directly with the derivative operator. So step one, we'll just show that we're going to take the derivative of both sides. E to the y cos x, we've got to take the derivative of that, so I put a prime there. Now what I mean, instead of using prime, you could also use d by dx. We're going to d by dx this whole thing here. But I don't like using d by dx just because it takes forever to write. So I'm just going to use prime. And that's going to mean d by dx. So that's left side. And on the right side, we need to do the same thing. We need to take the derivative of the right side. So 1 plus sine xy. And we need to prime this guy, which means d by dx. So first off, we've got e to the y times cos x. We need to take the derivative of this. That is the product rule. The product rule is the derivative of the first, which is e to the y. So derivative of e to the y is e to the y times y prime. We've got that times y prime because we're doing d by dx. All right, we need to use the chain rule here. If we were taking the derivative of e to the x with respect to x, it would just be e to the x times 1, because the derivative of x with respect to x is just 1. But the derivative of y with respect to x is y prime. So that's the derivative of the first times the second, which is just cos x, plus the first, which is e to the y, times the derivative of the second. Derivative of cosine is minus sine x. And that is equal to, now we need to take the derivative of the right hand side, so the derivative of 1 is just 0, maybe I'll write it for this time here, plus the derivative of sine of xy. So the derivative of sine of something is just cosine of that thing, but we've got xy on the inside, we need to take the derivative of the inside. We have to use a chain rule here. So the derivative of the inside, we need to use the product rule because it's x times y. So the derivative of x times y is equal to the derivative of the first, which is just 1, times the second, plus the first, which is x, times the derivative of the second, which is y prime. Okay, now strictly speaking, the derivative is done, but let's try and solve for y prime at least. So we're just going to do a bit of algebra here to get our y prime on one side, if we can, and then get everything else on the other side. So first thing, I'm just going to expand everything we have here. So we have e to the y, y prime, cosine of x, minus e to the y, sine of x, and that's equal to, we don't need the 0 anymore, so we need to expand this. We've got y times cosine of xy plus x y prime of cosine xy. So what I just did there is I just expanded this right side. Okay, now everybody who's got a y prime, let's put them on the left side. So this first part here can just stay. But now we need to move over this guy because it's got a y prime. So we subtract it from each side, so we have minus x y prime cosine of xy. And that is equal to, now we need to put everything else. So we've got the y cosine of xy, and now we need to go plus e to the y sine x. So all I did was just move this guy over here and move this guy over here. It's basically switch those spots. So now we've got our y primes on one side. Now we need to factor out a y prime on the left side. So we have e to the y cosine of x minus x cosine of x, y. And that is equal to, is there anything we can factor out here? Not really. One thing I'm going to do though is I'm actually just going to switch the order. I'm going to go e to the y sine x plus y cosine of xy. That's addition. We can switch the order either way we want. And you don't have to do this, but as we'll see right away, it just kind of makes the result look a little more symmetric. So now we need to get y prime all by itself, so we need to divide both sides by this big guy here. So finally, we're able to get y prime all by itself, and we've got e to the y sine x plus y cosine of xy on the right side, all divided by e to the y cos x minus x cos xy. And there you have it. We've managed to get y prime all by itself. So now, just a reminder that y prime is dy by dx. Right, so where it says find dy by dx, there we go. We've got it here. Now you can see why I switched the order. I just wanted on the top and bottom the first term to start with the EYs, and the second term has the cosines. It's kind of a nice little bit of symmetry here. Not something you really expect to see when you look at this expression, that we're going to have a nice symmetric result. Or maybe it's not symmetric. Maybe it just kind of looks nice. But anyways, that's it. That is implicit differentiation. It's kind of nice doing implicit differentiation. You don't worry about reorganizing before you get started. You just hit it with the derivative right away. The key thing to remember is that we're taking the derivative with respect to x. So anything that's got a y in it, you need to be using chain rule, because the derivative of y with respect to x is just y prime. It's not 1, right? Derivative of cosine of x is negative sine x. But the derivative of cosine y with respect to x would be negative sine y times y prime. Always got to remember to have that y prime in there. Okay guys, thanks a lot for watching. If you have any questions or suggestions, just leave them in the comments. Until next time.